Hello everyone, this is the first problem of today's educational round, and in this problem we're given that Monocarp wants to throw a party and he has n friends and he wants to have at least two of them at his party. Now the ith friend, best friend is PI and all PI are distinct. So Monocarp can send invitation to friends and the ith friend will only come if the invitation is sent out to both I and PI. So Monocarp needs to find what is the minimum number of friends that he has to send invitation to so that two friends show up to the party. So this is like, first of all, how many people solve this problem using something like DFS and cycle, finding out cycles? Is there anyone? Okay. Okay, someone used brute force. By the way, see, this is a very typical problem. You don't have to use any logic. See, let me give a brief idea. In this problem, if so, they were saying in this problem, first is the problem. Like if you are not aware of like DSS or like how like these, if we are given an array and every like we can consider that every node is pointing to another node. Like every 1 to n can be considered nodes, all the vector length. And one like one's best friend is 2, two's best friend is n, n's best friend is 3, three's best friend would be someone else. So if you're not aware of this, this always turns up into like you'll have at least one or more than one cycles. And every every number, every node will be part of some cycle. It will be like exactly one cycle. It cannot be that you have something like one, like you'll never have non-closing loops. So if you don't know what these terms are, loops, cycles, don't worry about it. It has nothing to do with this problem. The thing is, if you know these things, you could have complicated this problem. Like, if you don't know these terms, it's okay. It's not needed for this problem. But if you know this problem, these things, it's quite possible that you might interpret this problem as a like a minimum shortest cycle problem. Like you have to find the shortest cycle. But it turns out that that is wrong. Like you don't have to find the cycle. First of all, let's see if we invite any like three friends like this, we'll always get two friends in the party, right? Because for a for a friend to come up to a party, it doesn't like it's not necessary that he should also come and his best friend should also come. No, the only requirement is that he and his best friend should receive the invitation. So if the best friend doesn't even show up, doesn't matter. These two will, right? So we just have to check for any friend if his best friend is having the best friend same as this friend. Like if X is best friend is Y and Y is best friend is X, then our answer is 2. Otherwise, answer is 3. We just need to check this condition. And our answer can never be 1 because we need at least two friends that should come to the party, right? So we just need to check if there is a condition like X's best friend is Y and Y's best friend is X. Is it clear? Yes, no. Okay, so let me show you the implementation. So this is the implementation. In this, I have first taken the number of tests as input. Then I have taken the number of friends as input. And I have taken the best friends, like ith person's best friend is PI. So I have taken those as input. Initially, I have set my answer to 3 because in worst case scenario, my answer will be 3, not more than that. Then I have taken, like, I'm just iterating through my list of friends and I'm checking that if P of I, what does this mean? That the best friend for I minus 1. Why? Because I have my P, array P is 0 indexed. So P of I minus 1 means the best friend of ith person and P of that thing. That means best friend of that. If this is equals to I plus 1, why I plus 1? Because again, I is starting from 0. If this is true, then my answer is 2 and I can print it. Like, I'll iterate through the loop, but in this case, my answer will be 2 and finally I can print it. Is it clear? Okay. So see, if I have something like 1, not 1, 2, 1, 3, no. So the best friend for this person is this. 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 Best friend for this is this. So we just are trying to find this thing. If we have that two's best friend is 1 and one's best friend is 2. So I have done P of I minus 1. This thing is equals to I plus 1. So for I equals to 0, P of I will be 2. 2 minus 1 will be 1. P of 1 will be P of 1 is what? P of 1 is this thing, right? So P of I is 2 and then so P of I is 0 is 2. 2 goes to, so 2 minus 1 is 1. Let me break this down. I'm also getting confused. So P of I. So P of I, this value is 2 when I is 0. 2 minus 1 is 1, this thing. And this simply means that P of this complete thing is 1 and P of 1 is, like, I think P of is 2. Let me first see the condition that I have written. So I have P of I minus 1 is double equals to I minus. So we have, for this case, it will be P of I minus 1 is double equals to I plus 1. So for I equals to 0, P of 0 is 2 minus 1. So this is the best friend, that is this one, and P of 1. What is the best friend of this? It is, the best friend is 1. So P of 1, what is P of 1 in this array? It's 1. So this is 1, and what is I here? It's 0. So 0 plus 1 is 1. So you're getting that yes, the best friend of this, like, for I is equals to 0 is the same. Like, you're ending right back here. So that's why this is, you can see that it's a cycle of 2, or x is best friend is y and y is best friend is x. So that's why our answer is 2 in this case. Otherwise, we can always get 3 as our answer. Is it clear? Okay. So let's go to the next problem. So in this problem, we're given that let's define a cyclic shift of some string S as a transformation of S1 to Sn, as like Sn will come to the front and all the characters will shift to the right. So we can be given a string S and we can choose any substring of this string and perform this operation any number of times. But the cost of like performing this operation on a substring of size L or size S is equals to S. Then we need to find what is the minimum number, what is the minimum total cost in order to make the string S sorted. So let me we're given a string S which is binary 0, 1, 0, 1, 1. So we need to convert this to something like 0, 0, 0, 0, 0, 1, 1, 1. And to perform these operations, let's suppose we choose this as our substring from here to here. Then the length of this is 6, so 6 is the cost. And after applying operation on this, we would have received 0, 1, 0, 0, 1, 1. So now, how to find the minimum cost? We can greedily solve this. If we encounter a 0 and there's a 1 before it, we have to keep this 0 before 1. So what we can do, we can just check how many times, like if we encounter a 0, how many times before we have received 1. Then we can simply select this string. Is my voice not clear? Like how many people are facing this thing that my voice is not clear? Okay, it's clear. So probably like if you're facing audio issues, please check your internet once. Okay, so coming back, I have that I need to keep this 0 before these ones, right? So what I can do, I have to keep this 0 before this one. So let's say every time I encounter a 0, let's take this string only for example. So I have a 0, I don't have to do anything. There is no 1 before it. Then I encounter a 1. Okay. Then I encounter a 0. So this 0 should be before this one. So I select this as the string. Then again, I have a 1 here and a 0 here. So I'll select this as the string. Then I encounter a 1, 1 and a 0. So when I encounter this 0, there are 3 ones before it. And the position of these 3 ones are 1 is here, 1 is here, and 1 is here. And then there are these 2 zeros. So this 0 should also come before this, and this 0 should also come before this. In this way, see, anyway, this 0 should come before these 3 ones. There are 3 ones before it, and it should come before these 3. And when we are applying the operation, only the thing that is changing is one character from last is coming to front. So if you want this 0 to come before these ones, you'll have to select a string which is ending at this point. And you need to minimize the length of the string. Why? Because you have to find the minimum cost, right? So you should have the length of this string as this 0 plus all the ones that are before this. So 3 ones. So this is the most optimal way that we iterate through this string. If we encounter the 0, we'll try to bring this before all the ones that have occurred till now. So that's how we'll always make sure that there are ones continuously and then there is the current 0. So we bring this before here. Then there will be someone, then again there will be a 0. So there will all be ones here and there will be a 0 here. So we bring this here. Is it making sense? Yes, no. Okay, so this way, when we encounter a 1, we do count, let's say count of 1 plus plus, and if we encounter a 0, we'll add answer plus equals to count. Not count, count plus 1, because if we have 4 ones and 1 0, the length of the string that we are performing our operation on is count of ones, 4 plus 1, 5. So that's why count plus 1. Is it making sense? Yes, no. There is just one thing left that if count is 0, like you encounter a 0, like you encounter this 0, there is no one before it, so you don't have to add count plus one. In that case, you add zero. So instead of adding count plus one, we can add something like count plus count is more than zero. So this is a boolean. This will be 1 in case count is more than 0. That is, you have a 1 before and it will be 0 in case there is no 1 before. So let me show you the implementation. So this is the implementation. In this, I have first taken string s as input, then I have declared my answer as 0 and my count is 0. Count is the number of ones that I have encountered till now. Then I'm iterating through my string s, and if my current character is 0, then I'm adding in my answer count plus count is more than 0. So this is the boolean 0 or 1. Otherwise, I can just increase my count by 1 if I'm able to print my answer. Is it clear? What about others? Okay, so let's go to the next problem. So in this problem, we're given that we have an integer array A of length n, and we can perform the following operation. Choose any element of array A and replace it with its native value. And we, for example, A is equals to 3, 1, 2, then we can have all of these arrays. Our task is to find the minimum possible number of, like minimum possible total sum that the array can have if we are allowed to perform this operation at max a total of k times. So n is between 1 and 3 into 10 to the power 5, k is between 0 and 10. So this is the only, this is the thing that tells us that this problem is solvable using dp in either n into k or n into k squared. If you are not aware of dp, you can listen to me, but I would suggest that instead of mugging up the solution, just try to understand what is the basic approach we follow, and then surely you can try like start with basics and then you can shift to problems like these for up solving. But yeah, don't try to mug up. Even if you remember this solution, every DP won't have the same solution. So that's so in this we're given this. This is a very standard digit problem. If you are aware, if I have a value here, I can give this here or this here. Neighboring values can be made this thing, right? So usually what would happen if we have if we are propagating what is happening in here? We are propagating these values, a value which is minimum is being propagated, right? So how do you think we can propagate these values? On basis of what, basically? Not maximum difference, it is basically how low is the value, the criteria. Yes, how low is minimum value towards left or right. So what else do you think? If I'm at the ith point, what do you think is the state that on which you have to find? What is the second criteria? Anyone? For DP, you need to have state, right? So I'm asking you, yeah. The second thing will be how many times you have applied the this kind of operation. You can apply at max 10 times, right? You can propagate this value in direction k times. So the second thing would be how, like, you can have either remaining or how many times you have already done any of these. Like how many times you have already done or how many times you can do it more, right? Okay, this thing, this much is clear. So now the solution is pretty simple, that let's say I'm iterating through this. I'm using I to iterate over this. And at every point, I can iterate, like, first of all, if I'm not doing any operation using this, so everything, let's call f of ij as, like, remember this step. So I is the index and j is how many times, the operation or, like, let's say propagation has already been done. Like we have assigned the ith neighbor this value. So how many times this has already been done? Propagation already done, has been already done. So hopefully these two terms are clear to everyone, right? Already done. So in first, and what will this give me? Minimum sum of array that I can achieve up till I. Array from 0 to I, let's say, up till I, right? Of elements. So f of ij or dp of ij is giving me minimum sum of array up till I if I have performed the operation j times. Is this thing clear to everyone? Like, this is the basic thing that should be clear to everyone before going forward. What is the state? Because then only I can explain you the transitions. The transitions for this is very simple. There are two things in a DP solution, right? State and transition. So this is the state. And transition is how we move from one state to another state. Is this thing clear? Like, don't worry if you don't know DP. Still, like, forget about DP. This is the generic term I'm defining. Then I'll explain, like, how we can move from one point. Okay. So now, if you can perform only 10 times, then yes, greedy will fail. Like, how will you apply greedy? Like, it's, if you think about it, it's really difficult. How would you know whether you should do, like, it's not about just picking the minimum element and propagating it left or right. It's about, if let's say I have, like, if you want an example, take this one, two, 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 and there is a 99 and it's a couple of thousands around it. So if you can apply operation 5 times or maybe 2 times, it's better to apply it here and here rather than here and here. So it's not about picking the minimum element and propagating it. Now you might think I would take the, like, the minimum value and then propagate it. It's also wrong. Why? Because you can have something like the difference is, like, you're not getting that much difference here, but if you apply it twice, you would get a bigger difference. And on the other side, if you just apply it once here, you're not going anywhere. So let me give you that example also. So let's say there's a 10 here, 20 here, and a 30 here. And there is, on this side, you get something like 10, 10, and maybe 21 and 22. So let's say you're getting 20 and 31. So you see, if you apply here, you got 11. Like, you decreased the value by 11. And maybe there is nothing here. Like, there is 22 or there's the end of this array. And something similar to here. Let's say there was a 9 here. So you already wasted one chance here. but you could have done something similar here, 11 and 11. So you would have received 22, something like this, right? So it's, you will never know this greedily. Maybe there is a way, but like this, it would be like very, very, very difficult. Like, how would you identify? Is it making sense? Who asked me this? Okay, so coming back to this. So I have already defined what f of ij means. Now how to compute this? See, j is at max 10 and previous terms is also up till 10. So it's very simple. Just like you need to go this, like the value that is here can be propagated at max 10 indices further, right? It cannot be propagated 10 indices more than 10 indices further. So first of all, what we can do, for every value from, let's say we have, we'll iterate like f of ij is simply f of I minus 1, like whatever sum was up till I minus 1, j plus ai. Is anyone having any doubt in this? Like, we are not doing anything. Like, if I have applied j operations up till now, I'm saying, okay, up till I also I have done j operations and I'm just adding ai to it. I'm not doing any kind of operation. So if you know the meaning of these terms, it makes sense. And if you have to apply operation, what can you do? You can just iterate from current place. Let's say we only need to go in one direction, because if you're propagating, you just can propagate in one direction. Why? Because the other direction, if going towards right, when you go to next index, you'll come back, right? So that's why instead of propagating towards right, like when you are at some place, you don't have to propagate toward, yes, they will basically overlap with each other. I'm saying if you're at ith place, just go in back direction, like consider subarrays like this. You can consider like this also, but you don't have to, because this is already considered when you're at this point, I plus 1, right? So that's why just go in one direction, find the minimum of this, and you have the minimum this, you have what was the sum up till here, find f of I, how many operations have been done, the length of this, how many times the value have been propagated, and plus what how many times this value has been already propagated, along with anyone. Yes. What, like, let's say this is the length, I minus length plus whatever the minimum was times length, I minus length, and there would be a term here. So now, is it making sense? If I had done X operations up till now, I'm doing length more operations. Like, why length more operations? Because I've chosen that this minimum for this length, this subarray, length subarray, this is length. So length subarray minimum plus X operations are already done up till here. Minimum value in this length subarray multiplied by length. That is the value contributed because of this subarray and whatever was before this. Add this and this is your transition. Let me write this one more time clearly. F of I is equals to f of I of length plus x is f of I minus length of x plus minimum value whatever you got into length. So finally we can print f of n and k. But instead of k, like, is this first of all making sense why we can print f of n comma k? But there is one thing, that don't print k directly. Like this is might be you are having less elements than like k is, like n is less than k. So print f of n comma. Maybe you don't have, like you cannot propagate if you just have 3 elements and k is 10. You cannot propagate 10 times. So just print minimum of k comma n. So this is our final answer. Let me show you the implementation once. So like DP solutions are usually short, but like understanding them takes a little time. So I have taken n and m. Why n and m? Because like I have a habit, like I haven't taken n and k as input. I have taken n and m. Then I have taken array a values as input, and then I have initialized my first 0th index with 10 to the power 18. Like 0th index, all the values from 1 to n, basically 1 to k, with 10 to the power 18. And what I have done, I am iterating through the array, and for all the 0 to m, what I have done, f of ij, dp of ij is basically I'm initializing this. This is initialization part. F of ij is f of I minus 1 j plus ai. I am not including this in any operation, ith element. Then I shouldn't have done this directly in here, but like this is a variable just like for taking minimum. Then I can apply this operation. Like I'm propagating this from 0 towards I minus 1. Like I can apply operation from 0 to I minus 1, but not more than k times or m times. I'm taking the minimum, and my solution is basically n into k square. So I'm going from again from f of ik. So this can be broken down into that only. F of I of length is minimum of f of I of length, or f of I minus length, and this is length minus x. If you have the here length plus x, there would be x here. If you have length, if you just have length here, here you'll have length minus x. So basically these many, like whatever was left here, plus this is simply length into val. So I have written this thing in a little different order, but it is the same thing which was explained here. This thing. So then finally we can print f of n and minimum of n minus 1 or m. Why? Because you cannot perform more than these operations. If you have 5 numbers, what is the point of propagating 5 times? In 4 times you would be able to have the same value. If you have 1, 2, 3, 4, 5, first time, second time, third time, fourth time. So what is the point of propagating it more than 4 times? So that's why f of n comma minimum of n minus 1 and m. M is k. Is it clear? Okay, this is tabulation. Like, okay, let's discuss this after this session. Let's go to the next problem. Or maybe you can ping me in a query. Like sometimes I forget. Like I have solved these problems. Like I have solved this problem earlier. Like not exactly this problem, but many problems like this. It's only practice. Like believe me, it's not about. See, if you would have solved these problems like this earlier, then you would be able to write solutions like this. Like when I read this problem, I exactly know what I have to do. So like it's just practice, nothing else. Like it's not like, of course, like if you haven't solved DP enough, or if you are not aware of high states and transition, then at start you would be suffering a little. But other than that, that's like it's just a math stuff, right? If you solve it more, you would be more comfortable with it. Like it would come more intuitively to you. Otherwise, like TP solution is like if you directly look at somebody else's solution, you will be completely puzzled. You won't be able to by yourself. You won't be able to prove it. Why is that working? So let's go to the next problem. So Alice and Bob are playing a game in the shop, and there are n items in the shop, each having some price. It's different price for Alice and different price for Bob. Alice wants to choose a subset, possibly empty, and I like these are the items that Alice will buy. Now, let's say if Alice bought less than k items, then Bob can get all of those items at zero price. Otherwise, if Alice bought more than k items, then Bob can choose from those items, the items that Alice has bought. From those items, Bob can choose any k and get those items for free. And the rest of the items, the remaining items, Bob will get for exactly BI value. So we need to find what is the profit that Alice can have, and we need to maximize this value. And if both choose their subsets optimally, like Alice and Bob both, what is the maximum profit that Alice can have? So let me explain this problem. Like this is a greedy problem. Again, this is kind of classic only. Like if you have solved problems like this, then I don't think it would take much time. Like deriving the solution, I think can takes a little. If deriving the that proof can take quite a little time. But other than that, like this is the standard problem that is like I think it's similar to job scheduling problem if you're aware. If you're not, you can search it on internet. Like job scheduling problem is a very classical problem, and it's I think it would be available on LeetCode, GFG, and other platforms also. Like it's not always sorting on the basis of AI minus BI, but for this problem, like this kind of solution would work, but don't stick to this A minus B. For this, it would work, of course. Like something like this would work. But when I say a greedy, like, like instead of directly thinking in one direction that it is something like A minus B sorting, if we are given two values, instead of try to think of a proof, like how would you solve this problem, and you have to prove it that it would always work. Instead of coming up with a solution and then proving it, start from the proof, like what you have to do. So coming back to this, what we have to do, we are given something like A. But yes, you are right. Job scheduling problem is this only. You have to sort basis on these values, if that is what you meant. So we have A and B. So AI is the cost. AI is the cost to LIs, and BI is cost to Bob. Now, if LIs bought, let's say, these items, then first of all, Bob needs to, let's say, K was 3. So out of these 3 items, Bob will choose, let's say, this, and this. And these Bob will get at 0 value. And then these Bob will get at BI. So the total cost incurred by LIs is A1. Let's say the index is starting from 1. So A1 plus A3, A4, because these are the items that LIs bought, right? A4, A6, and A7. Let's say this is the cost. Then Bob's cost is B1 plus P4. So LIs bought at this cost, this is the total cost, and he sold to Bob at this cost. So the difference between these is the profit or loss, net profit or net loss incurred by LIs. Is the problem statement clear? What about others? Okay. Now tell me one thing. what should be, if you are allies, what items will you try to include in your set?
I think like the items usually have a maximum cost for Bob because like then he can just immediately get all of
Yes,
these for him.
yes. If you have to, like intuitively, if you have to think of something, you should buy those items that are having more value for Bob. Why? Because eventually they'll, like, some of those items will end up, like Bob will end up buying and he'll get more money. Right? Forget about what you, like, what you had to pay. Think in this direction that eventually Bob will buy those and you're getting that much money back. But okay, this thing is clear. So if we have to, like, first buy, then let's buy costlier items for Bob. But now there is another thing that instead of buying something at X and like selling it to Bob at X plus 1, why not buy something at Y and sell it to Bob at Y plus 100? So let me give you an example. Let's say there are two items, which one you buy for 1 rupees and Bob buys for 100, and there is another item which you buy for 1,000 and Bob buys for 1,005. So which is more effective, like more optimal for allies? The first one or second one? Of course, the first one, right? Because in that case, the net profit is 99. In the another one, the net profit is 5. Yes, here we are choosing the difference. So the, like, if there are two items, like, okay, this things, like earlier we discussed that we'll try to buy those items which are having more cost for Bob. But if you have two items, on what basis you should consider, like which item to buy, which item to not buy? If you have two items, on the basis of difference, right? Like which will give you more net profit. Is it making sense? And this is clear by the example that I've just given, right? Is this thing making sense to everyone? So let's say at you have this thing also, that what does the total difference between at what Bob can buy and what allies can buy? Then the problem is really simple, right? Let's say we iterate in this order that what is, like, we iterate in the order that it's like costlier for Bob, and cheaper for Bob. We buy iterate in this way. Forget about what we are having. If and then we iterate in this order, and what we can do. First of all, is there any optimal, like, optimicity if we are buying less than K? No, right? In that case, answer is 0. Like in that case, it's better to buy nothing instead of buying less than K, right? Because then we bought at some value and Bob gets it for free. So we are at loss, right? Instead of that, you should buy nothing if you're buying less than K items. So once we have bought, we have bought more than K items, what we can do for only K items, Bob will get for free, right? So Bob will try to get which items? Now forget that you are Alice. Consider you are Bob. Earlier we saw that it's better for which difference is more. If there are more than one items, it's better for allies to buy those for which difference is more. Typically, the difference between AI minus BI, like this value. And this is true for Bob also. Bob will try to get those items first for which this difference is more, right? So if you go in this direction, that costlier items for Bob to cheaper items for Bob, and out of these, you see that okay, these are the K items, top K items, which have the maximum difference. Those items will be bought by Bob simply. Is this thing making sense? If this is clear, then the problem is solved. Bob will basically choose those, like same analogy follows for Bob also. He'll choose those K items which has the maximum difference. between AI and BI. But I should say BI and AI. Like BI is the cost, like this value, if it's bigger, BI minus AI, then Bob will choose this first because it is costing him more and costing Elias less. So Bob should try to get these items for free. Now the problem like the problem is very simple. Just we need to iterate over the items in decreasing order of the cost. If the item, like currently there are, like we are in the last k items, then we can take the answer as whatever the result that is the result that we can get if all the items were there. Like if there are all the items like this AIBI, then the difference between this, difference between this, difference between this, difference between these, making sure that like if this is AI and BI, there is one more thing. If AI is less than BI, it's optimal for allies to buy. If AI is more than BI, then this is not optimal for allies. This is not optimal. Why? Why will allies buy something which definitely is cheaper for Bob? So we'll ignore these. And for others, we'll calculate for all of these, we can calculate a result. Like this is the maximum profit that allies can have. And then we can iterate over this. And for every K, we can get what is the for K items having the maximum, which have the maximum difference, what is the sum of those? And that can be subtracted from this result. Why? Because Bob will buy it. So let me show you the code, otherwise you won't get it. So see, first of all, I have N and K, then I have this C. So this C is basically BA, like cost for Bob, then cost for Elias, not vice versa, right? Then I have taken first C of I second. So this means cost of for Elias. And then I have taken cost for Bob as input. Then here I'm adding to my result maximum of 0 and this. So basically AI minus BI or BI minus AI. Like cost for Bob minus the cost for Elias. And I'm adding this only when this is more than 0. Because if Bob's cost is less than Elias's cost, Elias will never buy in the first place. Then I'm sorting in increasing order and I'm iterating in reverse order. So basically from more to less. I've used a priority key. You can use a set. You can not set multi-set. Don't use a set. If you use a set, set only has unique values. We don't need unique values. You can use a multi-set instead. If I is less than n minus k, this means that we have already bought n items. Like I said, if you haven't bought n items, then there is no point in for allies for choosing less than k items, because then Bob will get those for free. Once we have chosen at least k items, why n minus k? Because I'm iterating in reverse direction. If I have chosen less than, if I've already chosen k items, I can calculate my answer like this. What is the result and what is sum? Sum is nothing but what is sum? Sum is the items, cost of items in priority queue, like the difference in priority queue. And priority queue is only holding the topmost items which are having the maximum difference of this. Why? Because Bob will choose those only. So this just maintains, this is calculating answer, this if, and this is just making sure that we are inserting in queue, updating the sum. And if size of queue is more than k, then we remove the top from sum. Why? Because you cannot have more than, Bob cannot get more than k items for free. He can only get k items. So this makes sure that maximum size of queue, that is priority queue, is at max k. Finally, I am also updating my result. Result is nothing but result initially was the total, right? Total difference. Then from this, we can subtract this also. If we included the ith item, remove the ith item. So this way, finally, we can print our answer. So this is simply like iterating, and using this priority queue, we can get the cost of maximum, the cost of those key items which have the maximum difference, like this priority queue. Is it clear? So, okay, perfect. So that's it. And thanks for joining. Bye bye.